just one second. And just give me 1 second. I'm just sharing the recordings. Just 1 second. We had the class last. I will be sharing. Otherwise, I will then again forget and then go. I think so. I made your what did I do? Yeah, I made your email ID the Zoom new folder. Okay, I will do it afterwards. Otherwise, it will take a long time. And you shared your email ID, isn't it?
Yeah, sure did.
Okay, I will just do it afterward. Okay. So now we are going to move on to an empirical formula.
Okay.
Empirical formula. Empirical formula is what? It is the simplest ratio of an element. Like let's suppose that we are having, I'm writing just one equation, I'm writing just one of the numericals so we can solve it out. Okay. Let's suppose that we are having carbon, we are having hydrogen, and we are having hydrogen and carbon. Okay, so let's suppose that we are taking carbon as 40.0%, hydrogen as 6.67%, and oxygen as 53.33%. You have to find empirical formula. How will you do it?
The atomic mass over the percentage.
Okay, so that means over percentage, no. Percentage over atomic mass. That means 40 divided by 12. Basically, whatever percentage is given to you, that will be considered as your mass. It will be considered as your mass. Okay?
Yeah.
So
Okay.
whatever mass you are having, that will be considered divided by the original mass, as we are having 6.67 over here, divided by 1, as we are having 53.33 over here, divided by 16. So if you just do the calculation, you are going to get the ratio of 3.33 over here, 6.67 over here, and 3.33 over here. Now, the next step
Okay.
you are going to do, you will be looking at the smaller value.
Yeah.
The smaller value is 3.33, so make it divide by all the values. That
Okay.
means over here you will be getting 1, over here you will be getting 2, and over here you will be getting 1. You got a
Yeah.
ratio of
Okay.
1 to ratio 1, which means your formula will be CH2O. This will be called as your empirical formula.
Okay. Yeah.
So now, if the next thing is that you are going to, along with this, you have to find the molecular formula.
Yeah. Okay.
Molecular formula, what we do basically, you will be given with the mass. Like let's suppose you are given with the mass, and that mass is as 62. Let's suppose that is 62. So what are you going to do to find empirical formula? You will be having mass given divided by empirical formula mass. That means whatever mass is given, divide by empirical formula of mass, which will be 12 plus 2 plus 16. What does it give?
Um.
29, I think so. Is it?
Wait, no. It gives 1.05.
What is it coming as 1.05?
Yes.
Okay. Roundabout, I just wrote the rough number. So maybe like let's suppose this is 2 over here. Okay, it will not come in decimal, it will come in the numbers form. It will be 2, 4, 5, 6. Okay. So if you let's suppose that we have 2 over here. So what are we going to do? We are going to pick this 2 and we are going to get it multiplied with the empirical formula which we have. So that means you will be
Okay.
having now the formula as C2H4O2. This will be your empirical formula. This will be considered as your molecular formula. So did you got it?
Yeah. Okay.
Okay. So what are you going to do? You are going to calculate the moles first. After calculating the moles, you will be making the simplest ratio. The one which is smaller moles will be get divided by all the other moles. Then what you are going to get, you will be getting the empirical formula. That empirical formula, then to calculate molecular formula, you are going to divide mass given by empirical formula. Got it?
Okay. Yeah.
You will be having this thing. Okay, now let's suppose I'm writing one question. We are having carbon as 38.71. We are having hydrogen as 9.68. Oxygen as 51.51. 0.61%. Okay. Now,
Okay.
you have to find empirical formula. You have to find molecular formula when relative molecular mass is given as 62.
Okay.
Just try it fast, then we will move on to the next.
Okay. So first, empirical formula.
Just do it and let me know.
CHO. Okay. So, C. Hmm. Yeah, I got the answer.
Okay, so what answer did you got?
So for empirical formula, I got CH3O,
Okay, fine.
and for the molecular formula, I got C2H6 and
Okay,
O2.
well, 602, I think so. Isn't it?
Yes.
Okay,
Yeah.
this is correct. Now, the next what we have the formulas, as you know, that we have number of moles, and that is equal to what? That is equal to mass over molar mass. This is the first formula which we have.
Yes.
Then one more formula is there when you are going to find the number of moles for a gas. How do we find that?
Of a gas. I don't remember.
Then you are going to use a formula of volume
Over
divided
24.
by 24. Volume in
Yeah.
decimeter cube. Volume is also in decimeter cube. Getting it? Then what you
Yeah.
have, you can have one more formula which is concentration is equal to number of moles divided by volume. Okay.
Yeah.
And then one more formula which you have to keep in mind is moles is equal to number of particles, which is an atom and ion, or divided by Avogadro's number, which is 6.023 into 10 raised to power 23. Okay. These formulas should
Okay.
be on your fingertips.
Okay.
Let's suppose I'm writing one question over here. Let us do that. Find uh, find moles, no, find volume of CO2 gas which have mass of 1.2 grams. Now, what are you going to do? We have to
Uh.
find, okay, we have to find the volume in decimeter cube, and you are given with the mass. So, what should we do now? This is a gas.
Yeah. Okay. So wait, I'll do it. So more. Or 0.65.
How did you got it?
So first you find the moles. So
In the first, you find the
one
moles.
point.
The moles came as
Yeah.
0.216 multiplied by 2 plus 12, isn't it?
Yes.
Okay, and then moles will be getting multiplied by 24, isn't it?
Yeah.
You'll be getting a mole. Okay. Now, if one more question is there, calculate moles of H2SO4 sulfuric acid in 0.0 centimeter cube of a 0.1 mole decimeter cube solution. So what should we do?
Calculate mole in.
You have to calculate moles, but you are given with the concentration value. You are also given with the volume. So what should we do?
Okay. So you convert the centimeter cubed into decimeter
Yeah,
cubed
but you have to convert
by,
it into decimeter by dividing it by 1,000.
yeah,
So what answer
okay,
you get over here?
you can, yeah, 0.02.
0.02 as an answer. Okay. Now
Yeah,
concentration is equal to moles over volume. We have
yeah,
to find moles, which means concentration into volume is equal to moles. Is it?
yeah,
So concentration we have as 0.1 multiplied by 0.02, which is going to give you the moles.
yeah.
0.02 multiplied by 0.1
Uh,
is going to be
2 times 10 to the power of negative 3.
2 times 10 raised to power.
Negative 3.
Okay. That means zeros will come on your left side. Fine. This is your moles.
Yeah,
Okay. These all things we know already. We are just revising it. The next thing which is added over here is an ideal gas equation,
okay,
which is PV is equal to nRT. Okay. Ideal gas
okay,
equation is PV is equal to nRT.
okay.
So if you want to find just the number of moles, what are you going to do? N is equal to PV divided by
Yeah,
RT.
okay,
Okay. So now over here, 2, 3 values you have to learn. Keep it in mind that whenever you will be calculating the pressure which you will be taking in will be in Pascal. Okay, 1 atmospheric pressure is equal to 101,000 Pascal or 760 mm of Hg. Volume will
okay,
be in meter cube, and 1 meter cube is always equal to 10 raised to power 6 centimeter. Temperature
okay,
you will be taking always in Kelvin. So if you are having any temperature in centigrade, that will be added to Kelvin value, and you will be having the temperature in Kelvin. R value will be constant, and R value is 8.31 joules per mole per Kelvin.
okay,
Okay. Along with this, two things more is that as we know, PV is equal to nRT,
okay,
and as we know, N is equal to moles over MR. So we can write the equation as PV is equal to moles over MR, M over small m and over big M. Moles over MR, RT.
okay,
Okay, and from here also you have to calculate the density also, which is equal to mass over volume. So from this equation, if you check out, this is MR. From this equation, if you check out, are we having, if we bring MR on the top and we just do um, MRT divided by V and P. So this M over V is called as density. So MR will be equal to density divided by pressure. Got it or no?
okay, yeah,
Are you getting these?
yes,
Okay. So like see, we can convert from one equation. You can have a lot of calculation either for PV, either for MR, either for density, either for RT. So many of the equations can be done from here.
okay,
Like, let's suppose that we are having a gas what is the pressure? What is pressure if mass is 0.96 of oxygen gas, okay, and volume given, volume is 7 into 10 raised to power 3, temperature is 303 Kelvin. So now what you have to calculate, basically you have to calculate pressure, and we are given with,
Yeah.
as we know, PV is equal to nRT, and is what? PV is equal to mass over MR RT. Mass is given as 0.96 divided by MR will be what?
MR is going to be
32.
32.
Into 2 will be 32.
Yeah.
R value you have to learn, which I have already told you, which is 8.31. Temperature is given, which is 3.3.
Okay.
Now we have to find pressure. That means volume is also going to come down, which is 10 raised to power 3. Getting it?
Okay.
So now what you are going to
Yeah.
do, you are going to find them out and you are going to tell me the answer.
Okay. Mm, mm. 1388.13.
Now it's coming as, just calculate it again. Your answer should be 10791.
Mm, is that 3.3 or 303?
303.
Oh, yeah, tried again. I got 1388.
Okay, what did I told you that whenever you are going to take the pressure, that pressure, okay, now do remember that pressure should be in Pascal, but what if I want that pressure into kilopascal? Then what you have to do?
Times by 1,000.
Divided by 1,000. So if you divide this by 1,000, so what are you going to get then?
10.791.
Okay. 1. Okay, so now this is how you are going to do it. Okay, now one more question I'm writing and you will be doing it. I'm writing for you. You are having a volume which is 400 centimeter cube. Temperature is 300 Kelvin. Pressure is 101 kilopascal. And the mass is given as 0.65 grams. Assume that gas behave ideally. What would be the identity of gas? Identity means that you are going to find MR. Just do it. I'm waiting.
Miss,
Yes, yes, sir.
I did it, but I don't know if it's correct. I got 0.04.
0.04. No, we have to find MR. So MR should be what?
Yeah, I got 0.04 as MR.
No, it will not be an MR. Did you convert this centimeter into decimeter?
Yes, I did 400 divided by 1000.
No. Centimeter has to go into meter cube. So that means whatever answer you will be having for centimeter divided by 10 raised to power 6.
I don't understand. Can you explain again?
I'm telling you that see, whenever you convert centimeter into decimeter cube, you divide it by 1000,
Okay.
isn't it?
Yeah.
So now what we have to do when we will be taking an ideal gas, you will not be taking the value in decimeter cube. We are going to take the values in meter cube. Getting my point?
Oh,
So
oh yeah.
meter
Okay.
cube mean that it is much smaller than decimeter also. Sorry, much bigger than decimeter. Sorry. So it will be what? You will be dividing it more by 1000. So now this is
Oh yeah.
making what?
Okay.
This is making 10 raised to power 6.
Oh, okay. Yeah.
Okay. Just do it and then you will be getting a correct answer.
Yeah. I got 40.1.
Okay, now check from the periodic table which element is.
40. Okay. Calcium.
Okay, so this will be a calcium. Getting it?
Yeah.
Okay, so basically what we did 0.65 multiplied by 8.31 multiplied by 300, isn't it?
Yeah.
And we divided it by 0.1000 multiplied by 400 divided by 10 raised to power 6. Is it? We got the
Yes.
value.
Okay. Yeah.
Okay, let us do one more. So then this will be get over. Let us have one more. Okay. I'm writing this is the last one. Calculation percentage yield. If I am having 4 point, okay, for percentage yield, do remember is always equal to actual yield divided by calculated yield